Welcome to Accelerated Engineering. My name is John, and this is the video encyclopedia entry for the ATAN2 function, or arctangent 2, or however we want to say it. Arctangent 2 takes an input x and y coordinate and returns an angle based on those coordinates. So as we can see, I've plotted a unit circle in blue based on taking the sine and cosine of an angle and plotting those on an xy graph. And then I took the arctangent 2 using the cosine as the input x coordinate, or x num, and the sine as the input y coordinate, or y num. And what this does is it allows any point in Cartesian space to be accurately described by an angle. And what we can see is the outputs of this, by taking the sine and cosine again of my output angles, is that no matter where we go in Cartesian space, any angle input can be mapped accurately to the same angle output. You can see my red dots with an input and output pair. There is no reflection, there is no missing, there's no sliding. The only reason that those values or those circles are slightly off center is because I added a multiplier to make sure that you could see both of them all the time. Yeah, and then input range for the arctangent 2 function is anything, any number that Excel can represent. You can take the arctangent of it. You can think of it as being, well, I guess it's any pair of numbers, and it will tell you the angle that would point to that space, or point to the point described. Related functions to this would be the arctangent function, sine, cosine. Those would all be good functions. But that's it for arctangent 2. Be sure to like and subscribe to the channel if you haven't already done so, and if you want to see more content like this. And drop me a comment if there's something in particular that you wanted to see that hasn't been addressed yet. As always, this concludes the video encyclopedia entry for the arctangent 2 function. Thanks for watching.